Hi class. I want to run through this handout on Turing machine examples with you just to give us a little bit more practice. We ran out of time when we did it in class, so let's take it a little bit more slowly. Here's a Turing machine to start with, the first one on the handout. Let's give these states some numbers so that we can talk about them. Whoops. Let's see here. Okay, that looks okay. Alright, now let's see if I can write. Here we go. Let's call that state 2, let's call this state 3, and this one state 4. Now I can use a name to refer to it. Notice that this machine begins here. This machine's drawn a little bit differently. The start state's labeled with a name instead of a number. And then there are two cycles that the machine goes through to come back around to the start state, either that one or this one. And eventually the machine hits a blank when it's in the start state and will go to the halt state, which is the accept state. So the question is, what language is this machine designed to accept? And the way that I would suggest that you analyze this is by staring at the machine and figuring out what it does. But it takes a little bit of practice to do that. So just to get us started, let's run through some strings and just trace the behavior of the machine on that string and write down whether or not the string gets accepted, and then maybe we'll see a pattern or something and we can use that to further our understanding of this machine. So suppose that the machine is started with nothing but blanks on its tape. So blank, blank, all blanks. Now it doesn't matter where the tape head starts, but let's say it starts right there in the start state. Alright, there's a transition here out of the start state and back to the start state, but you have to have a star on the tape to take that one. You have to have a B on the tape to take that one. You have to have an A on the tape to take that one. But here's one for blank. If you see a delta, leave it a delta and move your tape head to the right and go to the halt state, which means that the machine would accept that string. So accepted strings, let's make a list of the strings in our language. Lambda is the first one that we see. What about the string A? Here's a tape. There's a blank. Here's an A. There's a blank. Tape head starts right there. And we'll start in the start state. Now if you see an A out of the start state, you take this transition. And that says if you see an A, change it to a blank and go to the right. So this would become a blank and our tape head would move over here to the right. And we'd be in state 3. In state 3, is there a transition for a blank? That's what we're on right now. These don't say you can take them for blank. This doesn't say you can take it for blank. So whoops, crash. Our machine crashes on the string A. What about the string B? I think we can just do that in our heads. If you're here and you see a B, you can go over here, but then you'd be on a blank if it was only a B that you had to start with, and the same thing's going to happen. You would crash. And so for B, the machine crashes. What about AA? I'm choosing strings in lexicographic order. Well, if we get an A to start, we've seen what happens. We can go here. So let's just do it again. Here's our AA string. So here's a blank. Here's an A, and all blanks after that, and we'll start our tape right there. Now, if we're in the start state and we see an A, we change it to a blank. In other words, we erase it, and then we go to the right. So we change that to our blank to get it erased, and we go to the right. So let me erase where my, where my tape head is, and we'll go to the right. And we're now in state 3. So in state 3, if you see an A, here's a transition. If you see an A, leave it an A and go to the right. So our tape head is going to go over to the blank that was at the end of the string. It's going to be right here. And we will still be in state 3, and that same old thing happened that happened a minute ago. We do not have a transition for a blank out of state 3, so we're going to get a crash. And that would happen if you had 1A, 2A's, 3A's, 4A's, whatever number A's you had. Those strings are not going to get accepted. What about an AB? Check that out. A, B. Alright, we're right there. That's an A. In the start state, C and A, change it to a blank, go to the right. So that gets erased, and our tape head goes over there. I'm just going to cross that out. I'm on the B, and I'm in state 3. In state 3, if you see a B, you can change it to a star, a splat, an asterisk, and go to the left. Alright, so that's interesting. I better erase this. Quit being lazy. So that B gets changed to a star, and the tape head moves to the left, and I'm on a blank, and I'm in state 4. In state 4, let's see, this is for A's and B's and stars. Here's one for blank. If you see a blank, leave it a blank and go to the right. So we're going to move our tape head over here to where the star was, and I'm feeling lazy again. So we're here on the star, and we are now in the start state. The start state has a thing to do for stars. If you're on a star, erase it and go to the right. So this star changes. I'll erase this while I'm at it. I'm erase this while I'm at it because I'm getting ready to go to the right. That changes to a blank. It was a star, and my tape head goes to the right, and I'm sitting on another blank now. And still in the start state, and oh look, I get to go to the halt state. See a blank, leave it a blank, and go to the halt state. So that is an accepted string. I should have written accept up here too. So AB is the next string in the language if you write it in lexicographic order. Now if we run BA through the string or the machine, that same thing's going to happen. Look at this. Here's the B. It'll take us over here. Then here's an A. We change that to a star and go back left, and then we will be sitting on that blank, and we'll get to come up here, and then we'll get to accept. But let's do it. Here's the string BA. BA, and we're sitting right there in the start state. See a B, make it a blank, go to the right. So that gets erased, and we're over here on that A. Not here anymore. We're on that A in state 2. C and A, change it to a star, go back left. Alright, so now we're over here, not there. Well, I'm getting so lazy. I better erase those. Here. We're right there, and where have we been? We went here, and then we changed that A to a star and went left. Okay, so we're in state 4, sitting on a blank. See a blank, leave it a blank, go to the right, and go to the start. So that would take us over here, where if we are on a star, we change it to a blank and go to the right. And this would be a blank, because everything is if it's not one of the letters of your string. So we would accept, go to the halt state. So this gets accepted. Now, you know, is it true that at the end of a processing, any string that gets accepted has left the tape completely blank? That does appear to be true. This one did. This one did. And this one did. Left the string blank. AB, BA. Alright, so far we see some things about these strings. They're all even length, but the string AA was even length and it caused the machine to crash. So the language is not strings of even length. What else could it be? Well, it could be that the number of A's and the number of B's is odd. So let's test that theory with AABB. Or how about, well, no, we already tested just plain AA. Let's try AABB, see what happens. Start here. Sitting in start, if you see an A, you erase it and go to the right, so that gets erased. And I'm over here. You know what I'm going to do? I'm getting tired of erasing all these little marks. I'm just going to put a little dot. I'll drop my dot down lower as I go. Alright, so here we go. I'm here now. I erased 1A and I'm here. Sitting in state 3. State 3, if you see an A, you leave it an A, you go to the right. So now I'm over here and I'm going to drop my dot down just a little bit lower. In state 3 still. Okay, if I see a B, I change it to a star and go to the left. Alright, so this is going to change to a star and I'm going to go to the left, which is over there at this one. And where am I? I am here in state 4, sitting on this A. And state 4, if you see an A, you leave it an A and you go to the left. Alright, so I leave it an A, now I go to the left, and I'm sitting right there on this cell where there's a blank. And in state 4, if you see a blank, you leave it a blank, you go to the right. Alright, so now I'm back here on this A, and I'm in the start state. Alright, so now if I'm on an A in the start state, I change it to a blank and I go to the right. So change that to a blank and I go to the right and I'll be over here in state 3. In state 3, if you see a star, you leave it a star and you go to the right. Alright, so now I'm over here on that B in state 3. If I'm in state 3 and I see a B, I change it to a star and I go back to the left. So that B becomes a star and I go back to the left. So now I'm over here on a star, and I'm in state 4. In state 4, if you see a star, you leave it a star and you go to the left. So I would go to the left. I'd be on this cell right here, that blank. State 4, if you're on a blank, you leave it a blank, you go to the right. You go to the start state. So leave it a blank, go to the right. I'm here now. Pretty soon I'm going to be off the movie. I'm right here in state start. If you're on a star, you erase it and you go to the right. So this star is going to get erased and this star is going to get erased, and I'm going to end up over here, right there, on a blank, and I will go to the halt state. So AABB did get accepted, and it left the tape blank, just like I noticed a minute ago. So AABB gets accepted. And I see now what this language is. Do you? It's the language equal. So one way you can see what a machine is doing is just run a bunch of strings through it and hope that a pattern emerges. Or you can argue about it. It's kind of this way. You've got two cycles. That's this one and this one that take you back to the start state. And each time around this cycle, you will be changing a B to a blank. All these loops this loop changes stuff, but these loops right here, they don't change things, and these loops don't change things. They just run over things and leave them like they were. But you're changing a B and you're changing an A. B's get erased and A's turn to stars when you go around this loop, and this just leaves the blank that you end up on alone and goes to the right to get ready to go again. Now if you end up here on stars, you erase them and you keep going to the right. It's an interesting sort of addition to the machine. That's how it erases its tape at the end. Here, if you're back at the start and you're on an A, you change that A to a blank and you change later a B to a star, and then you go around. So every time around this one of these loops, you're changing an A and a B. And you're erasing one of them. You're erasing the first one you came to at the left end of the string. So you're erasing from the left. And at the right end of the string, if you erase the B, you got to go find an A. And the first A you come to, you're going to turn it to a star, and then go back leftward to the beginning again. And then you erase if the first character you're on is an A, you erase it, and then you go looking for a B. And the first B you find, you change it to a star, and then you come back around. So every time around, you're changing an A and you're changing a B. And at the end, you're going to erase all those stars. And the only way to go to the halt state is if you've managed to erase all the stars and you're on a blank. If you are in the process of erasing stars and you come to a letter, an A or a B, well then you got to start around one of these cycles again, and you're going to get somewhere and crash. If you found a B and you started down this cycle, if there's no A, you're going to crash. And if you start down this cycle, come to start around this way, and you find, because you found an A and you erased it, now you got to go find a B. If you do not find a B, you'll be in this state right here and you'll crash if you come to the end of the string. So that's equal. Now let's look at that other Turing machine. Here's the next Turing machine on this worksheet, and it's rather small in this video, and so what I want to do is break it into two pieces. We'll analyze the top part separately from the bottom part, and that'll give me a little bit of room to write, and I'll try to make the top part a little bit bigger so you can see it better, but I just wanted you to see the whole thing so you'd recognize it on the worksheet. Well, I can't really make it any bigger because it gets all blurry when I try to, so hopefully you'll be able to see this all right on the video. Okay, so here we are in a start state, and in the worksheet it said that the machine begins with its cursor or its tape head on a pound sign, which is just to the left of the first letter of the string. So this transition just takes you to the first letter of the string. And it can be either an A or a B. What happens is you change it to its uppercase equivalent, and you go to the right. Here, in this state, you find another A or B, and you don't change it to anything, you just skip over it to the right. So let's see, I want to make a string that we can practice on. Alright, so let's do this string. A, B, A, B, A, B, A, B. Okay, so and we had a pound here. So we were in the start state, and our tape head was sitting here. And then we went to the right. And we were in state 1. And it said, if you see an A, change it to a capital A and go to the right. So this guy got changed to a capital A, and we went to the right. In state 2, if you see a B, you leave it a B, you go to the right. So now we're here on that A, and we're in state 3. State 3, see anything, A, B, whatever, you just keep going to the right and you don't change them. So we will be moseying along all the way down here to the end of the string in state 3. And when we get right here, in state 3, it says see a blank, leave it a blank, go to the left. So we will be there on that final B, and we will be in state 4. Now, in state 4, if you see a B, you will change it to a capital Y and go to the left. So here's my B getting changed to a capital Y, and I'm going to go to the left. I will be on that A right there. And I will be sitting in state 5. Now state 5, there's two ways to go. One way is if you see a little letter, either B or A, and the other is if you see a capital A or B. Well, we're on a little a, so we'll leave that a little a and go left to state 6, so we'll be right here. In state 6, there's a loop. It says whatever you see little letter-wise, keep going left. So we will be going left, going left, going left, going left until we get all the way over here to this capital A, and we'll still be in state 6. State 6, if you see a capital A, you leave it a capital A, you go to the right. So we will be on that B right there, and we will be sitting back in state 1. Now let me erase some of these dots. I'm on this capital, no, I'm on this little b right here in state 1. And what did I accomplish with that trip around? I changed a little a to a big A. I changed the little b to a big Y. Notice that it was the first letter and the last letter that got changed. Alright, state 1, if you see a B, you make it a capital B, and you go to the right. That's what that says right there. State 2, if you see a little a, you leave it a little a, you go to the right. So I'll be right there on that A. I'll be in state 3. State 3, all little letters keep you going to the right. So go boom all the way down to this Y right here. All that in state 3, taking this loop. Now when I hit that Y, it says leave it a Y and go to the left and go to state 4. So I will be on that A right there in state 4. In state 4, if you're on a little a, you change it to an X. And you go to the left. So now we're right there on that little a. In state 5. Now in state 5, if we're on a little letter, we keep going, go around again. So we just go left on that little letter to here. State 6, all little letters keep you going left. So all the way back over here to this capital B, staying in state 6. We're in this tape cell right there. And if we see that B, we leave it a B, go to the right, we'll be on this A right there, back in state 1. So let me erase all those things. What have we accomplished? We changed, whoops, I didn't mean to do that. We changed 2 letters now on the left and 2 letters on the right. We're changing A's over here to capital A's and A's over here to X's. B's over here to capital B's and B's over here to Y's. And if we go around again, what will happen? We will end up changing that to a capital A and that to an X. And then we'll come back and we'll be on this A right here. Then we'll change that to a capital A. And we'll go down here and back up one. We'll change that to a Y. Now, what happens this last time around? Let's be real careful. Where do you change a B to a Y? Right here. So we just changed that B to a Y and went left. So we would be right there sitting in state 5. And we go again. We go around again because we're on a little letter. So we change, we don't change anything. We see that little A, we go left to here. And in state 6, see a little B, go left. So now we go to this capital A. And we see that A and go right. So now we're on this B right here, and we're in state 1. Now, last time around, in state 1, you see a B, you make it be a big B. And you go to the right. So we're on this A right here. In state 2. State 2, if you're on a little a, you go to the right. So now we're in state 3, and we're sitting on a Y. See a Y? Go left. So now we're here on that A in state 4. See an A, make it an X. And go left. So now we are on this B right here in state 5. And now we get to go down. So I've got to go get the rest of the machine and see what happens. And look, we go leftward. When we find that capital B, we're going to go leftward. So we're going to be right there on that A, and we need the bottom part of the machine. We'll be in whatever state comes next right there. So let me make a little copy of this part of the screen here. And I will get the rest of that picture. Alright, here we are. I've got the top of the machine now, and remember we were on this A right here. Well, let me get my pencil again. We're on this A right here, and we just entered this state. Look here on this loop, it says either capital A's or capital B's keep you going leftward and you don't change anything. So we will march along all the way down to this pound sign. And when we get there, we'll see a pound, leave it a pound, go to the right. We will be right there on the first A of the string, sitting in state 8. Let me erase this and this. So I'm right here in state 8. Now, in state 8, I've got two ways to go. There on a capital B, there on a capital A. So see a capital A, change it to a pound. Change it to a pound. And go to the right. So I'm over here. In state 10, if you see capital B's or splats or A's, you just keep going to the right and you don't change anything. So I'm going to keep going to the right until I get over here to this X. And when I get there, I will change it to a splat and go to the left. So this guy changes to a splat and goes back to the left now. So here I am on that B, having made that change. In state 12, if you see capital B, leave it a B, you go to the left, splats same, A's same. So I will march along until I come to a pound. That's not something that keeps me going around this loop. So pound is different. I'll be right there in state 12. See a pound, leave it a pound, go to the right. So I will be sitting on that B right there. Now what have I accomplished? I changed a capital A to a pound and a capital X to a splat. Now, notice that I started down this road because I was on a capital A. That capital A used to be a little a. If I had been on a capital B, I would have gone this road because it's treating A's and B's differently. And when I get here, I have to find a capital X in order to continue around this cycle. And I can't find a Y. Look, if I had only capital A's and B's and splats keep me going here, I have to find an X and not a Y. And so once I do find that X, I change it to a splat and I go back. Alright, so it's looking to me like this is probably doing double words. That A had to match that X, and both capital A's and X's used to be little a's. It found the middle of the string on that top part of the machine, didn't it? And it changed everything in the first half to capital A's and B's, and it changed everything in the second half to capital X's and Y's. And now it appears that it's going to work from the left-hand end of the first word and the left-hand end of the second word and make sure that those things, that A's match X's and B's match Y's. So let's see. I started with a double word on here because I was suspicious that that's what this machine did. And I think that is what it's doing. So let me erase some dots here so we can keep up with where we are. We're sitting on that capital B at the left-hand end of the string. And we're back in state 8. So see a B, that takes us this way. Make it be a pound. We are erasing things as we go, on the left with pounds and on the right with splats. See a B, go to the right. So now we're on that A right there in state 9. In state 9, if you see capital A's or B's or splats, you keep going to the right. So we will go to the right until we get all the way down here to this Y. And we will change that to a splat and go back to the left. So now we'll be here on this splat, sitting in state 11. In 11, if you see splats or B's or A's, you just keep going left. And so we will go left, left, left until we come to that pound right here. And then we will see this transition. See a pound, leave it a pound, go to the right. And we will be back in state 8 on that capital A. So I do believe that this is doing double word. It has to match B's to Y's and A's to X's. Now how's it going to end? I always like to trace it through to the end, but I take some shortcuts. So I know that this is going to get changed to a pound, and the machine will come down here and change this to a splat, happily, because A's and X's go together. Then it'll come back and it'll change this to a pound and go down here and change this to a splat because A's and X's go together. And then it will go back and it will find this splat and take a step to the right and be on that B. So I want to trace through that last little pass. Whoops. To see how this ends. So I'm on this B right now. And I'm back in state 8. I'm going to go around one more time. See a B, make it be a pound. Go to the right. So I'll be on that splat right there. And to the right over all splats. So doing, 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 all the way down here to this Y. And see a Y, change it to a splat and go left. So make it be a splat and go left. And I will be right there on that splat in state 11. All splats from state 11 keep you going left around that loop. So doing, 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 all the way down here to this pound, and still in state 11. See a pound, leave it a pound, go to the right. So I'm in state 8 now, and I'm on that splat right there. Okay, now I see how this ends. If I have just made a pass where I changed a capital letter on the left and a capital letter on the right, and I've come back, if there's another capital letter to change, then I got to go around one of these loops again. But if I have changed all the capital letters in the first half of the string, then I'll be sitting on a splat, and I will then go down here, go to the right on that splat, which will put me on the second splat. This sends me all the way to the end of the string. So I'll go doing, doing, doing to a blank, and once I hit the blank, I will be able to go to the halt state. Now, I'm not really quite sure why it couldn't have accepted when it first saw that splat there, because it already made sure that the word was equal length, even length, and so because it divided it in half, and it managed to check off a letter and a letter and a letter and a letter. I'm not sure why it had to go all the way to the end. I might not be seeing something right now, but I'm a little suspicious of that. However, it's certainly not wrong to go all the way to the end. And so I am convinced that this machine is doing double words. So now, if you continue looking at that worksheet, you will find that you are being asked to not draw Turing machines, but to figure out how to recognize certain languages with Turing machines just by writing an algorithm. And here's an interesting one that I want us to talk about. Strings of all A's, where that n is a power of 2, and it can be any power greater than or equal to 0. So what kind of strings are even in this language? What is that trying to say? Well, if n is 2 to the I and I is 0, then n is 2 to the 0, which is 1. So a to the first is a string in this language. The next power of 2, when I is 1, 2 to the 1 is 2. So the next string is going to be AA. When I is 2, n is going to be 4. And so we will have strings whose lengths are powers of 2. Next one would be 8, next one 16, and so forth. Now, how in the world are you going to design a Turing machine that will accept strings whose lengths are powers of 2? That's an interesting question. I'm sure we will discuss this in class, but let me give you a big hint. If you have a number that's a power of 2, say 32, and you divide that by 2, you get another power of 2. And if you divide that by 2, you get another power of 2. And you can keep doing that all the way down to 1. If you take a number that is even, but is not a power of 2, and you divide that by 2, well, we got an even number again. We divide that by 2. We get an even number again. But sooner or later, we're going to come to an odd number other than 1. That was not a power of 2. Do you believe this? How about 60? Divided by 2, we get 30. Divide that by 2, 15. Bummer. Okay, what about 20? Oh, that was boring. Same thing happened. Let's try 48. 48 makes 24, then 12, then 6, then, oh, bummer, 3. The only time that you can keep dividing by 2 and eventually get down to 1 is if you started with a power of 2. So now, how can a Turing machine use that little nifty factoid to do its business? What could the machine do with a string of all A's to check whether or not that string was a power of 2 in length? Let's have a string that is length 16. There's 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. How do we divide a string in half? Well, I think we should erase half of it. So now remember, there's a blank there and there's a blank there. We can use those blanks as delimiters. And we'll start our tape head right here. Now suppose we make this be something different just to mark it. Maybe make it a capital A. And then go all the way to the right till you come to a blank and take a step back and erase that. Now go all the way back to a capital A, take a step to the right, change that one to a capital A, go all the way down here, take a step back to the right and erase it. If you keep doing that over and over and over again, you will, whoops, goofy, whoops, you will, your Turing machine will do a better job than I'm doing. Erase half the string, and you will have turned the other half, I almost did it again, you will have turned the other half of the string into capital A's. You will eventually, the part where you have to change behaviors is always a little tricky, so I get careful right about now. Alright, come down here, find a capital A, take a step to the right. If it's a little a, change it to a capital A, go till you find a blank. Find a blank, take a step back, erase, go left until you find a capital A. Now, if you find a capital A on your very first step left, that means you're done with that pass. So you have divided your string in half, and now the left half is all capital A's and the right half is all erased. Well, I'd like to reuse that part of my Turing machine. So what I'm going to do is I go back left is change all these things back to little a's so that I can reuse the Turing machine just like it was set up initially, expecting a string of all little a's. And I'll find this blank, take a step to the right, and it will be as if my initial tape had a string of 8 A's on it, because in effect it does now, right? It has 8 A's and then all blanks. So I can just repeat exactly the process that I went through to start with. Now, how do I know when I'm finished? How do I know that my string doesn't go bad somewhere along the way and turn into a string of odd length? Oh, we haven't even thought about that yet. Well, let's do another string over here. Let's have a string of length 6 and see what happens. We start out here or here. Change that to a capital A, go to the right, doing, 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 to a blank, take a step back, erase. Go back to a capital A, step to the right, it's a little a, change it to a big A, go to the right to a blank, take a step back, erase. Go to the left to a capital A, take a step to the right, it's a little a, change it to a capital A, go to a blank, take a step back, erase. Take a step back, we're on a capital A. We're doing the same thing we did before. We're on a capital A, so happily we start changing all these to little a's, and we get back to the beginning. And we take a step to the right, and we're ready to go again. Okay, now let's go again. Change to a capital A, go to the right to a blank, take a step back, erase. All the way to a capital A, take a step to the right, change it to a capital A, go find a blank, take a step back. Whoops. That's not a little a, that's a big A. So we need to build our Turing machine so that once you've hit the right-hand end and you've taken your step back, you have to be on a little a to continue. That little a gets erased and you can continue. But if you're on something other than a little a, in particular, if you're on a big A, your machine needs to crash. And so you just wouldn't put that transition into the machine. If you're on a big A right there, the machine has no transition and you would crash. So that's how you detect odd length strings. You don't get to erase a little a on the other end after you change a letter on the left end to a capital. Then there's not one on the right end to erase. But there's one little thing left to do. What is that little thing left to do? We got to check to see if we start out like this. If this is where we start, or if this is where we end up after we've made a whole pass and erased half the string, or if we've made a bunch of passes and erased half the string each pass, and we will eventually end up here, we got to check to make sure that we notice that we have a string of length 1, and so we should go to the halt state. So what we have to do at the very beginning of our machine, and we do this the very first time the machine starts to run, what it has to do is it starts on a little a. It has to have, the shortest string is little a, so the very first letter that the tape head's on, it has to be a little a. If it is, it needs to take a step to the right, and if that is a blank, go to the halt state, because you're finished, and that's a good string. But if it's not a blank, then take a step back and then do all this mess that we were doing earlier. So that is the algorithm for powers of 2. Now, what would you do if you wanted to do powers of 3? What if you want to recognize strings like this? A to the n, where n is 3 to the I for I greater than or equal to 0. What do? What are powers of 3 anyway? Those aren't ones that just come into our heads. Well, start with 1 and keep multiplying by 3. You've got 1, 3, 9, 27. Next one's 81, and then what's the next one? 243, right? 8 times 3 and 1 times 3. And then I don't know what the next one is. Anyway, you see the deal. Okay, so what do we do now? Suppose we got a string of length 9. How in the world are we going to recognize that that is a power of 3? Well, I bet the same thing kind of happens. If you start with a power of 3, like 81, you divide by 3, you're going to get a number that can be evenly divided by 3, and that one can be, whoops, no, well, yeah, you could if you could divide by 3, and then that one could be divided by 3, and then eventually you get down to 1, right? Same kind of thing, except now you're dividing by whatever power it is that you're doing. Well, how do you take a string and divide it by 3 so that you only have a third of it left? You've erased 2/3 of it and you have a third of it left. Well, that's not too hard. We change 1, go down here and erase 2. Come back here, change 1, go down here, erase 2, and so forth. Change 1, erase 2. It wouldn't be all that much different than our machine for powers of 2, and you could do this for any power. You just change 1, and you erase the power minus 1 thingies out here on the end. Here's an interesting one. This is on the worksheet too. A to the n, b to the m, c to the p, where all of those things are greater than or equal to 1. So you have to have 1 of each kind of letter at least. And the number of c's is equal to the number of a's times the number of b's. So what do good strings look like? Suppose you had 2 a's and you had 3 b's. Whoops, b, b, b. Then you have to have 2 times 3 6 C's. I believe you used a pumping lemma to prove that this language is not context-free. But it can be recognized by a Turing machine. We just need to figure out how to recognize it by a Turing machine. What would we do? There's a blank there. There's blanks down here. Well, let's think about nested for loops. We're programmers. Let's think about nested for loops. What do we have to do for each A? For each A, we need to check that there are however many B's you have, C's, and we need to erase them or something or mark them. For each A, then for each B, you mark a C. So let's try that. I want to see if this works. Let's mark this guy because this is the A I'm currently working on. So for that A, I come down here, and then for each B, I need to mark a C. So now I got to keep up with which B's I've already marked C's for. So how about I change a B, go down here, change a C. I'll make them capitals. Come back here, change a B, go down here, change a C. Come over here, change a B, come over here, change a C. Come over here. Now there's no more little b's left, and when I'm going backward over the C's that I've already changed, if I come to a little b, it means I need to keep going. But if I come to a capital B without having seen a little b, then it means I've finished doing the for each b mark a C part. So I think what I want to do here is change all these b's back to little b's. On my way back leftward, and then if I come to a little a, I keep going. When I come to a capital A, I take a step to the right and I need to go again. So at that point my string would look like this: blank, capital A, little a, B, 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 C, 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 blank. And I'd be sitting right there on that capital A, or little a, sorry. And I need to do it again. For each little a, then for each little b, mark a C. So I would mark that A to remember that that's the A I'm now doing. Go to the right. And every time I see a little b, I make it be big, and I go out here and I find a little c and I make it be big. Come back left. I'd go left until I found a big B, skipping over big C's and little b's till I found a big B. Then I'd take a step to the right, and if I'm on a little B, I'd go again. Big B, go out here, skipping over little b's and big C's till I come to a little C. Make it big. Go back left, skipping over big C's and little b's till I find a capital B. Take a step to the right, make that a capital B. Then go out here, make this guy big. Go back left. If I come to a capital B and I take a step to the right and I'm not on a little b, that means I've done this part for each b, mark C. So I go backward and I change all these back little again, just in case I need to go again. I find a capital A and I take a step to the right, and I would be sitting on a little b right there, which means I have done this nested for loop. I have marked for each A a B and a C, marked off a C for every B. Now, how do I make sure that I had no extra letters? Well, what I've got to do is march along, going rightward until I hit a blank, and I have to make sure that there are no more little C's out there. If I'm able to complete this exercise, this nested set of for loops, enough time that I have managed to mark off every A, and I was always able to mark a C for every B, and there are no more little C's hiding out here at the end, then my Turing machine should accept that string. Okay, that's enough. I will leave the rest to you. Thanks for listening.